Hey friends, my name is C and you're watching here MakesItEasy, and welcome back to a new video for A-level mathematics. Today we have 5.1 for the volumes of revolution around the x-axis for the questions video. And we'll get right into the first question, but before we get into it, don't forget to leave a like, subscribe, and ring the notification bell so you don't miss any future videos. And we'll get right into the first question, and these questions are from exercise 5a from the textbook. So here's question 1. Find the exact volume of the solid generated when each curve, or this curve right here, is rotated through 360 degrees, or basically 2 pi radians, around the x-axis between the given limits of x equals 0 and x equals 2. So we know the general formula for the volume of revolution, or like the volume generated when we rotate through 60 degrees around the x-axis is given by volumes, like volume, V equals pi times the integral of y squared dx from x equals 0 to x equals 2. X equals 0 to x equals 2. Or like in generally, it's just x equals a to x equals b, right? So in this case right here, part A, the volume will be equal to pi times the integral of y squared, which is 100x to the power 4. 100x to the power 4. Because that's basically 10x squared, right? 10x squared. And dx from x equals 0 to x equals 2, right? So this will be equal to the pi, or like what I can do is that I can just take out the 100 first, so it'll be 100 pi times by the integral of x to the power 4 dx from 0 to 2, like so. So it'll be 100 pi times 1 over 5 x to the power 5, 1 over 5 times x to the power 5, and like so, the bounds. So we know this will be equal to 100 pi times 1 over 5 times 2 to the power 5, minus, like basically substitute x equals 0 in here. But it'll get 0, so we can just ignore the 0. So it'll just be 100 pi, it'll be 100 pi times by 1 over 5 times 2 to the power 5. And let me just put into my calculator. So 100 pi times by 1 over 5 times by 2 to the power 5. And this gets us an answer of 640 pi. And we usually leave it in terms of pi so that it's easier to understand it. So 640 pi. And it doesn't give us any units, so I'll just put unit cube like so. In question 2, the curve with equation y equals root 3x to the power 4 minus 3 over x cubed is shown in the diagram on the right, like so. The region bounded by the curve C and the x-axis and the line x equals 6 is shown shaded in the diagram, and the region is rotated 2 pi radians around the x-axis. Find the volume of solid generated, giving your answers to 3 significant figures. So let's just start off by doing volume equals pi times the integral of y squared, or integral of y squared. So 3x to the power 4 minus 3 over x cubed squared dx from x equals something to x equals 6, right? So we have to find what the lower limit is. Because we know the upper limit is 6, so we have to find the lower limit. So what we can do is that we can just look at this curve right here. We know that the value here is when y equals 0. So we just have to put y equals 0 in this case. So 0 equals root 3x to the power 4 minus 3 over x cubed. Solving it gets us, let me just put it out. It will get us 3x to the power 4 minus 3 equals 0, because what I did is that I basically times both sides by x cubed and square both sides, because this remains as 0 anyway. So x to the power 4 equals 1, because bring the 3 over and divide by 3, and therefore x equals plus or minus 1, but in this case we look at just the positive 1, plus 1, like so. So we know the lower limit is x equals 1. So just simplify the whole expression, so it will equal to pi times the integral of like so, and 3x to the power 4 minus 3 over x to the power 6. because we basically just get rid of the square root, but this remains, you have to square this, and dx. So what we can do now is that we can basically just split the integral into two different fractions. So pi times 1 over, like so, from 3 x power 4 over x power 6 minus 3 over x power 6 dx, like so. And now we can just, we can factorize the 3 out first, so it would be 3 pi from the integral 1 to 6 of 1 over x squared minus 1 over x to the power 6 dx. So now we can just simplify the whole thing, equal to 3 pi times the integral of, because this is basically x to the power of minus 2, so x to the power of minus 2, x to the power of minus 2, and this one right here is basically x to the power of minus 6. So using the reverse chain rule, we know that this integral right here would be equal to minus 1 over x, and this one right here will be equal to x to the power of minus 5 over minus 5, which is equal to basically minus 1 over 5 x to the power 5. So this the minus cancel out, so it will be plus 1 over x 5x to the power 5, x to the power 5, like so, and write the bounds, which are 1 to 6, like so. 1 to 6. So we basically just substitute the values in. So substituting x equals 6 will get us, let's just put my calculator, minus 1 over 6 plus 1 over 5 times 6 to the power 5, and that is minus 6479 over 8,880 minus when x equals 1, which is minus 1 over 1 plus 1 over 5 times 1 to the power 5. That gets us plus minus 4 over 5. So minus 4 over 5 gets us plus 4 over 5. And if we were to simplify this, it would be 4 over 5 minus 6479 over 38880 times by 3 pi. And simplifying it gets us an answer of 5.97 unit cube, like so. And moving on, we have the diagram shows a curve with equation 5y squared minus x cubed equals 2x minus 3. The shaded region is bounded by the curve and the line x equals 4. The region is rotated around the x-axis to generate a solid of revolution. Find the volume of solid generated. And this I will assume it's rotated around 2 pi degree, so 2 pi radians around the x-axis. So we know that we're given the bound already from x equals 1 and x equals 4, and we're given the curve. So what we do here is that we have to first rearrange to get y or y squared the subject. So we have 5y squared minus x cubed equals 2x minus 3, like so. Oops, let me just write it properly. X cubed minus equals 2x minus 3. Rearranging it gets us y squared equals 1 over 5 x cubed plus 2x minus 3, like so. So it would be tempting to do to just square root both sides to get y, but remember that in the integral we need y squared, so we basically already have y squared right here. So we can just remain as it is and just move on to the volume. So volume equals pi times the integral of y squared. In this case, it's already 1 over 5 times x cubed plus 2x minus 3 dx from x equals 1 to x equals 4. So, and I'll just pull out the 1 over 5 first. So 1 over 5 pi, and integrate it. It'll be 1 over 4. Oops. It'll be 1 over 4 x to the power 4 plus x cubed minus 3x from x equals 1 to x equals 4. And this will be 1 over 5 pi times, and just put into my calculator. So substituting x equals 4, it'll be 1 over 4 times 4 to the power 4 plus 4 squared minus 3 times 4. That gets us 68. So 68 for the first value. Minus the second value, which is when x equals 1. So 1 over 4 times 1 to the power 4 minus 1 squared, plus 1 squared minus 3 times 1, that gets us minus 7 over 4. So minus 7 over 4 gets us plus 7 over 4. So just simplify the whole thing. It will be 1 over 5 times 68 plus 7 over 4. So 68 plus 7 over 4 gets us 279 over 4. Times by 1 over 5, that gets us 279 over 20. And times by pi, and that gets us 279 over 20, and everything times by pi unit cube, like so. And moving on to the last question, we have quite a fun question. So the diagram shows a shaded region, a shaded rectangular region R of length h and width R. The region R is rotated through 360 degrees around the x-axis. Use integration to show the volume V of the cylinder form is V equals pi r squared h. So the nice thing about volumes of revolution is that when we have a rectangle like so, if we were to rotate around the x-axis, it will actually form a cylinder. And it's a bit hard to visualize in the 2D dimension or the 2D graphs. So if you were to draw like a 3D graph, like the draw the y-axis here and the x-axis over here. So let's say we have the line, this one right here, right? When it's at R, like so, right? And if we were to rotate it around the x-axis, well, in this case this is the x-axis, we know that the let's call this radius R, right? That means this radius is R. That means if we were to rotate around the x-axis, all the radius would be R, like R, right? That means basically it'll form a rectangle, like so. It'll just rotate around the y-axis, sorry, the x-axis, with radius R. Like this will be, the radius will be R, like from the own point it'll be R. So it'll basically form a cylinder. And it's a bit hard to visualize, or draw it out. So the best thing to do is just to basically search online some proof to show that it actually forms a cylinder. Or maybe you can visualize it yourself, which is great. So what we can do is that we can first consider the equation of the line. So the equation of the line is just y equals r, right? So therefore y squared equals r squared, right? So to find the volume of this, normally we just do v equals pi times the integral of y squared. In this case is r squared. The r in this case from x equals it will be dx, not dr. Dx, and the bounds are basically the origin 0 and h, right? So this will be equal to pi times the integral of r squared x from r equals 0 to r equals h. So basically we just substitute the values in now, right? So we substitute x by h in and x minus 0 in, and basically minus both sides. But you know s equals 0, that means this will make this 0, so we can just ignore this root right here. So substituting x by h, that gets us v equals this new color, v equals pi r squared h, which is what we have for the volume of the cylinder, and that's the final answer. And that's it for this video for 5.1 for the volumes of revolution around the x-axis for the questions video. And I hope you'll find it useful and helpful, and if you did, please leave a like and subscribe and ring the notification bell so that you don't miss out on any future videos. And if you have any questions or any comments regarding my channel or my YouTube or my Instagram, you can leave them down below and I'll reply to them. And check out my social media in the description, and if you need any learning resources or any teaching resources, you can check out my website in the description, or you can type it out in your browser at www.MakesItEasy.com. And I hope you'll find it useful and helpful, and I'll see you all in the next video, which will be 5.2 for the volumes of revolution around the y-axis, which will be similar, but it will rotate around a different axis and different squared function. But anyway, I hope you'll find it useful and helpful, and I'll see you all in the next video. Until then, stay safe and happy learning.